Okay, here we have a toolkit squaring function, and we've actually sketched it explicitly on an XY coordinate system with the red dot at the origin. Now I'm going to randomly pick a point. Okay, I'm going to do this. I'm not looking, not looking, not looking. Okay, there's a point. I think that's it. I don't even know where it is. So let's say it's here. Okay. So I picked this point. And what I'm going to do is I'm going to put a red dot at this point. Now, having put a red dot at this point, I'm going to construct my square. Sometimes we call this fundamental square. Try to make it as similar as possible to this square. It's about the same size, it's still kind of square. Okay. And then I'm going to, and notice this is pretty badly sketched. Look, my low point is over here at about -1/2 almost. Okay. And it's not clearly not symmetric with respect to the y-axis. It was not a good attempt at sketching a decent route. So I'm going to try to do a little better here. Well, that's too sharp, but that's okay. Should have flattened out a little more. So when you do it, obviously you're going to do much better. Okay. So this graph is the graph of y equals x squared. Well, this graph has a function. Okay. There's an algebraic way of writing an equation that represents this graph. Y equals something. And it's really pretty easy to figure out. Okay, so what I'm going to do is I'm going to extend my x-axis. What's the coordinate? That's the coordinate of this point. Well, I'm going to move 4 units at a time. Yeah, I'm going to say that x equals 6 about here. And if this is x equals 6, it's possible that this left-hand corner is for x equals 6. Okay, so that the x coordinate of my dot, which is called the vertex of the parabola, incidentally, is at x equals 8. And of course, then that means that this side is x equals 10. Because again, the square is supposed to be identical to this. Okay, now what about the y coordinate? That's going to be a little tricky because actually it's a little lower than that. Okay. What's my y coordinate here? Okay, let's be real clear about what line this is by putting it in a different color. Okay. If I divide my interval from 0 to 4 in half, I get this. So that's about where y equals 2. I'm going to divide this in half, and I'm going to be a little bit below this mark. So I'm going to make an honest estimate. Okay, if this is 2, then this would be 3, and this would be 4. So I'm going to say y is about I'll use a little wavy thing above the equal sign to show this is an approximation. I've estimated it from my graph. Y is approximately 3.3 according to my estimate. Okay. Now I'm going to tell you what the equation for this parabola would be, assuming that this point is the point a 3.3. Okay. What I've done is I've shifted this graph 8 units to the right and 3.3 units up, because of course I trace what happens to the origin. To go from x equals 0 to x equals 8, I moved it 8 units, very clear, and I had to move it up 3.3 units. Okay. So graph shifts plus 8 units horizontally. Plus 3.3 units vertically. So my function y equals f of x equals x squared okay, we're going to call this f of x. We're going to call this one g of x. So this is y equals f of x. And of course, this is y equals x squared, so f of x equals x squared. And I've got all that written in this equality here. I'm going to call this one y equals g of x. Okay. Now, there's something that goes in here, but I'm going to write out the equation for g of x. It's just x minus 8 squared plus 3.3. That's it. Okay, that's the equation. Now, I've used function notation. Not everybody coming into this class will be conversant with function notation. As a matter of fact, I tell this just so you don't feel bad about something that might be deficient in your background. I went to a top 10 school of science and technology. Okay, it wasn't top 4, it wasn't the elite. It was semi-elite. Okay, I wasn't good enough to get into the elite schools. But it was one of the top schools, but not the top of the top. Okay, and they didn't offer any math below calculus. And I had high SAT scores. They were high enough that I think the only thing I missed on the SAT was I didn't know what function notation was. I'd had really good algebra courses, really good trigonometry, and then instead of a pre-calculus course, I had a course in mathematical logic. Well, that was very valuable to me, but it knocked my SAT scores down a little bit. Still, they were pretty strong. So I was there in their calculus class with students that had the stronger SATs, not the top strongest. There was an accelerated calculus class. I couldn't, that's for people who already had some calculus in high school. And calculus is generally not taught in high school at that time, and I'm not sure it's a good idea to be teaching it in high school at this time either. Brains aren't sufficiently developed at the age of 17, let's say, necessarily to really learn calculus. Anyhow, there I was at age 17 in this calculus course, and I didn't know function notation. And it was an adventure. I got through it, but I didn't do great. All right. So my whole point of that is, if you don't know function notation, don't feel too bad, but you're going to have to learn. So I'm going to go on with it. And hopefully, if you do, you'll understand how I'm using it here. If you don't understand it when I use it here, I'll give you some explanation. I want you to think about it, don't worry too much about it. Okay, we'll go through it in much more detail. Okay, so y equals g of x equals what? I say it's x minus 8 squared plus 3.3. I won't prove that to you, but I'm going to make that very plausible. Okay, y equals g of x, and we can write that as f of x minus 8 plus 3.3. Now, why is f of x minus 8 plus 3.3 equal to x minus 8 squared plus 3.3? Because f of x equals x squared, and I've replaced x by x minus 8. So I got to replace this x by x minus 8. That gives me x minus 8 squared. It's actually quite simple. If you understand that, you understand quite a bit already about function notation. And if you didn't understand that about function notation, now you understand something maybe a little more. Okay, and it should be helpful too. All right. So that's it. That's actually kind of cool. Let's see if that really works. All right. Let's just test this. Let's take a point on this graph. Now, you can pick your own point, but I'm going to pick a really convenient point. I don't want to pick this point because it gets a little too obvious, but we'll do that next. I'm going to pick this point. This point is what? X is 10, and Y is, well, Y is 3.3 here, and you go up 4 units higher, you're going to get 7.3, right? So this is the point 10, 7.3. Right here, in front of your very eyes. It's bad arrow, so it didn't obscure anything. Okay, well, let's see if 10, 7.3 satisfies this. If x equals 10, not 7.3, y equals x minus 8 squared plus 3.3 is equal to now you can evaluate this, so don't sit there and watch me evaluate it. Evaluate it yourself. You probably do it in your head quicker than, you might not even need to pause the video. Pause the video for 10 seconds and figure it out. Okay. So anyhow, we replace x by 10. We get 10 minus 8 squared plus 3.3. And do this arithmetic yourself. If you haven't done it by the time I write it down, pause and do it. Okay, that gives us 2 squared plus 3.3, which is 4 plus 3.3, which is, lo and behold, 7.3. Exactly what it should be. Okay, so the point 10, 7.3 is on the graph of g of x. If this is the algebraic expression for the g of x function. Now you can check any point on this graph. You could say, well, I know if I go over 1 unit here, I'm going to go up 1 unit because the point 1, 1 is on this graph. If I go over 1 unit from here and up 1, that's going to put me at 9, 4.3. So I get x equals 9, you're going to get 4.3. Take any point that you know to be on this graph. Take what we get if we shift any of the points for x equals -2, -1, -1/2, 0, 1/2, 1, 2. We know what the values of y are on this graph. Take the coordinates of that point, add 8, and move up 3.3, whatever numbers you get. the y is going to equal what you get. If you do this same thing. So I would recommend you at least do it for this point and this point. And then probably where you cut this interval in half, do this point, and maybe this point. And maybe all 7 of the points, and that's 3 of them. Only takes seconds to do any one of these once you understand where the point is. And if you understand the point, if you understand how to do this for any point, you're getting the point of this idea of transformations. Okay, now transformations work the same for any of the toolkit functions. So if I have the basic toolkit exponential function in here, it transfers over here, and the y equals 2 to the x will become 2 to the x minus 8. So that's 3.3. Okay, so I'm going to kind of draw that out, but don't necessarily expect you to sit there and watch me. So I'm going to do that, and then in a separate video, we'll kind of address what happens with the other 2 toolkit functions.